Today I will be discussing about the conservation of linear momentum. So in the last class we have discussed about the impulse momentum theorem. First we are going to take that equation of impulse momentum theorem. In this equation you can see clearly that if there is no external force acting on the system, okay, if this is zero, in that situation initial momentum of the system is equal to the final momentum of the system. Okay, so this is known as the conservation of linear momentum. Okay, here we need to note that if external force acting on the system is equal to zero, then this initial momentum of the system would be equal to the final momentum of the system. Okay, understood? So you can note the statement for the conservation of linear momentum, which says that if the net external force acting on a system is zero, okay, then the momentum of the system is conserved. Okay, net external force acting on the system is zero, then the momentum of the system is conserved. Okay, so in vector form we can write this equation as the sum of the initial momentum of the bodies in the system is equal to the sum of the final momentum of the bodies in the system. Okay, this is the equation for the conservation of linear momentum. Now what we are going to do is, now let us discuss about the impact collision. Okay, so what do you understand by the term impact? Now if there is any event, okay, in which there is a large amount of force that is acting between objects for a very short period of time, then such force is described as impulsive force. Okay, and in physics we call such event as impact. Okay, so you can note down the definition for impact. Now let us consider two bodies. Okay, let us say this to be body A and this to be body B. Now this has mass ma and this has mass mb. This is moving in this direction with velocity ua, and this is moving in this direction, same direction, with velocity ub. Okay, now in this situation we need to take one assumption, that is ua is greater than ub. Okay, then what will happen? Okay, if this velocity is more than this velocity, then at some point this will collide with this body, so collision occurs. Okay, in this situation let us take that this body collides with this body. Okay, okay, and during this collision what will happen, we'll analyze first. Okay, after collision there is like some force, okay, acting on this body due to this body, which can be written as force on B due to A. Okay, and there is a equal and opposite force that is acting on this body due to this body, which can be written as force on A due to B. Okay, this is A and this is B. Now after the collision this will have certain final velocity, that is VA, and this will also have some final velocity, that is VB. Okay, Now what we are going to do is, we have already said that this force is equal and opposite to this force, which means that the magnitude of force, this one, is equal to the magnitude of AB, okay, but the direction is opposite, okay. You need to note that fact. Now first of all, what we are going to do is, we are going to take this whole two object as a system, okay, this to be a system. In this situation, we can see if both is considered to be a system, then the internal forces, this force as well as this force, can be neglected and there is no external force, okay. In this situation, external force is equal to 0, so we can say that the initial momentum of the system is equal to the final momentum of the system. Now this can also be written as sum of the initial momentum of the bodies in the system equal to the sum of the final momentum of the bodies in the system, okay. Now there are two objects, that is A and B, in the system, so the sum of the initial momentum can be written as MAUA plus MBUB will be equal to the final momentum, sum of the final momentum, that is MBVB plus MAVA plus MBVB, okay. So this is a very important equation which can be used in case of impact collision and can be used to evaluate the velocities when there is impact collision in a system, okay. Now if you see carefully here, in this case, okay, we have taken both as a system, but if we consider only this object to be a system, okay, only if we only object A is considered as system, in this situation you can see there is an external force, that is this acting on this object, okay. When there is an external force, then we need to write this equation, which is the impulse momentum equation, that is initial momentum plus the impulse that is acting on the system is equal to the final momentum, okay. Now in this situation, initial momentum of this is MAUA plus external force that is acting is F on A due to B dt is equal to the final momentum MAVA, okay. So this is the equation in case where only A is considered to be a system. If only B is considered to be a system, then in that situation MBUB plus F on B due to A dt is equal to MBVB. This is the equation for case where B is only considered to be a system, okay. Now you can see we have already said that FAB is negative of FBA, so if you replace this in this equation and add both the equations, you will get this equation, because this and this is getting cancelled in this situation. This is just negative of this, so if you add both the equation, this and this will get added and this will get added in this side, so this equation will be coming, okay.